again, Copper Canyon Algebra 2, it's Miss Castro. Welcome back. You should be on 9.5 in your Edgenuity lessons by now. 9.5 is all about graphing sine and cosine functions. A little different from graphing regular functions that you're used to, like lines and parabolas and stuff like that. So first of all, you might notice that the graphs I already have outlined here are a little more long in the horizontal way than they are squarish. It kind of looks like a little piece of tape. So it's kind of unusual, but you want to get used to doing that because sine and cosine, in fact, most of your trig functions have sine wave type look to them, okay? They're not the typical just like a line that goes straight across. So this is why our graphs are more horizontal than they are squarish. All right, so talking a little bit about the importance of sine and cosine. So trig functions like sine and cosine represent waves and cycles. Most importantly here is there's lots of things out there that run on patterns and cycles like that. For example, your clock. You know, your clock on the wall has, you know, midnight, boom, straight up and down, right? 3 o'clock, boom. 6 o'clock, boom. 9 o'clock, boom. Back up to 12. I just made a cycle, full turn, right? So that's where the word cycle comes from. It comes from circle, right? It makes one full circle, one full turn. Lots of things do that. Your washing machine, you know, the water level fills up, goes down, fills back up, goes down. Lots of things have cycles on them. Ferris wheels, when you're going to like a carnival, a Ferris wheel has a cycle. So I wanted to physically show you something that had a cycle on it. It's one of my daughter's toys. She has a lot of cycle stuff. So something like this is a perfect example of like a cycle because you can see that this little merry-go-round just turns around, turns around. So to give you an idea of what we're going to be doing in terms of cycles and patterns is I want you to focus your attention on this little monkey dude here. And goes on this here. So right now, if you're thinking about cycle, look at the position of the monkey and also look at how close he is to you right now. So this is the closest this monkey is going to get to you right now if I keep this merry-go-round right here. So think of this as the starting position as the monkey. So the monkey's right there, but if I give this merry-go-round a quarter turn, just a quarter turn, look at the location of the monkey now. Now he's on the far left corner, and he's actually gotten a little bit further away from you, right? Give it another quarter turn. Look at where the monkey's at now. When I give it a full turn, this is a full turn now because I made a quarter makes a full turn. Now you can't even see the monkey. He's totally behind the back of this merry-go-round. He's also the furthest away he's ever going to get from you. This is as far as he gets. Okay, if I give it another quarter turn, voila, now you see the back side of the monkey, but he's actually getting closer to you. In fact, he's almost back to the beginning where he was. And if I give it a last quarter turn, voila, the monkey is exactly back where he was. This is a perfect example of cycles and how they work. It is a cycle. It has a beginning, goes through a certain motion, and gets back to where it started. Hence, the monkey's back where it started, and it's in the exact same location as where it started off, but it made a full cycle. We call that a full cycle. It did its full turn, right? So lots of things like that in terms of trig. Okay, electric waves, you know, they run on AC current. AC current has, you know, its wave pattern to it. Radio waves, they call them radio waves for a reason. They also have like some sort of trig function to it. So a lot of things, sinusoidal waves, all that stuff. But today I'm going to show you the basics, and so let's go ahead and get started. I already have a sine graph ready to go and a cosine graph ready to go. I haven't plotted it yet because I want you guys to see how to plot it and also to memorize some patterns that they have. So starting off, take a look at the values I already have here. So on this long stretch of graph here, I've already got some key values. Pi over 2, pi, 3 pi over 2, 2 pi, and then I went back to 5 pi over 2. So think about where those sound familiar from, and then you'll know where I'm getting them from. Think about pi over 2, 2 pi over 2, 3 pi over 2, pi, 2 pi. If you haven't guessed it yet, they're all coming from your unit circle. Okay, I'm not going to spend this much time on it, but I just want to quickly show you. Remember, your sine graphs are the y values, your cosine graphs are, or cosine values are the x values. And so take a look at those values. Here, here's 0. Here's pi over 2, here's pi, and here's 3 pi over 2. And then going back to 0 would actually be a full turn. That's 2 pi, a full turn, right? So I'm actually getting these sine and cosine values from these key points right here. Okay, so let's go ahead and take a look. Let's see the patterns. Hopefully it's not too bad from there. All right, so let's start with our sine graph right there. So at sine 0, 0 degrees, okay? So we're talking about the degrees here with these radian measures here. 0 degrees, the y value is 0. So we have a point right at 0. Boom. Make a big fat point. 0, 0, that's kind of like the center spot, starting spot, right? I'm going to go and write start here. It's your starting part of your graph. All right, so the next degree value we have here is pi over 2. Pi over 2 is a 90 degree. So at the 90 degree mark, you have a y value at positive 1. So now we're going to make a value at pi over 2, comma 1. So this is our point. Pi over 2, comma 1. Here's your point right here. Pi over 2, 1. That's your coordinate. Okay? So the next one is pi. That's a full turn. So when you do a full turn, you're back at 0. So here's pi over 2 right here. We have a point right back at 0, so back at center. If you want to, you can go ahead and give this coordinate a name, pi, and then 0. We're back at center. All right, then you're going down to the 270 mark, that 3 pi over 2. So the y value there is actually negative 1. So from here, we're going down to negative 1. So this is 3 pi over 2, negative 1. All right, and then we're going a full turn circle all the way back to the beginning. And remember, back to the beginning, it was at 0. So right here at 2 pi, we're back at 0. So this is 2 pi, back at 0. This is where the graph technically ends its cycle. Keyword ends its cycle. It's just going to repeat itself. If I had a stamper, I could just keep repeating those points. Let's go ahead and actually graph it though to see what kind of picture this actually makes. Now when you graph a trig function like sine or cosine, you don't make zigzaggedy, like mountain looking things. You make nice curvy waves, right? Smooth. So starting from this first point, we're going up here to that one, down here, and then all the way down to the bottom point there, and then to my ending spot. So that's what a sine graph typically looks like, okay? Main thing here is I don't expect you guys to pull out your unit circle every time you do this. So there's a bit of a pattern to a sine graph. And so here's how this pattern works. A lot of times we use words like center high, center low, center, that kind of stuff. That's exactly the pattern and words I'm going to use here to help you memorize a sine pattern. So sine patterns always start at center, dead center, right in the middle, okay? So we're going to call this center. If you think about the next point's actually a high point, so we're going to say high. Okay, center, high, back to center. Okay, center, high, center. Now we're going to a low spot, so I'll call this low, and then back to center. So if you had to think of a pattern for a sine graph, this is always the pattern that a sine graph typically takes. Center, high, center, low, center. Kind of got a little bit of a rhyme to it too. So very, very pattern-like, something to memorize. Pretty easy if you get used to it, but again, center, high, center, low, center. Okay, that way it has this kind of wave-like to it till it finishes. Okay, so that's your sine graph. Let's go ahead and pick out some information here. I just went ahead and wrote some vocabulary here real quick to kind of help you match. So max. Max just means, what do you think it means? What's the highest y value you hit? Now it has to be a y value, that's the thing. So going to this graph, you can see we had a high point right here, right? So think to yourself, what was that y value? What was that highest point? That highest point had a y value at 1. So your max value here, you can say, well, it had a high point at 0, 1, or pi over 1, pi over 2, 1, right? That was the max point. Some of you might just say 1, that's the highest it got to. You could just say 1, because technically that was the highest y value. But if you wanted to put a point to it, you could say, oh, it hit it at pi over 2, 1. Good. Either way. Same thing with the minimum. Minimum means exactly what's the lowest point. We had a low on this graph, right? It was right here. So same thing. You can either list the point. You can say, oh, at 3 pi over 2, it hit a low at negative 1. So that could be your minimum point. Or you could just say it had a low at negative 1. That's the lowest y value it got to. You could see it either way. Personally, I think this is just enough. Saying, hey, it hit a max y value at 1. It had a low y value at negative 1. Boom. That would be enough. All right, these two right here, domain and range. Domain and range are what they used to mean before, so they haven't changed. Domain and range still mean, domain are the x values, range are the y values. That has not changed. Now, here's a nice thing for these trig functions. They're waves. They don't ever stop. So pretty much on all of these graphs, your domains are going to be all real numbers. So you really don't have to worry about that because this thing is just going to keep going and going and going. It doesn't end. All right, the range though. The range is important because the range has to do with your max and your min. What were those intervals? What was the highest point? What was the lowest point? And you have to list it in an interval form or inequality form, actually. I think that's what they use on Desmos. So we already know that our high was 1 and our low was -1. So when we list this, we want to put it from low to high. So let's list the -1 first. So I'm going to say -1. And for those of you who remember me saying, you want to use these inequality notations. Less than equal to y, less than equal to 1. We always use this notation here for inequalities. It's not anything major. I just told you, hey, when you see those two inequalities together, it really just means between. So it's between -1 and +1, boom, done. Always list your low first, so that's key. All right, your period. Your period has to do with how long does it last? What time period does it take to get from your beginning to your end? You know, to make a full turn on a clock, it's from, it takes 12 hours. That's how long it takes, 12 hours to get from 12 o'clock in the afternoon, boom, to all the way to 12 o'clock midnight. It takes 12 hours to do that period. That's the period of length. So same thing here. How long did it take to get from the beginning, your starting point, to your ending point? That's kind of a nice way to say complete one cycle. So for most of these today anyways, we're going to be saying it takes from 0 to 2 pi. So period length here, 2 pi. That will change in future lessons, but for this lesson, really we just need to worry about, hey, it's 2 pi length. That's how long it always is. It goes from 0 to 2 pi because that's our unit circle, right? All right, your amplitude. I haven't talked about amplitude, but amplitude is just half the distance between your max and your min. A lot of people get confused because they think they have to count that total distance, but you're only counting half. So what I tell people to do is go to the center line and just count that half distance. So for example, right here, here was your center line, right? So the distance here to here is just 1, okay? So think of it like this. Oops, wrong marker. Think of it like this. You just have from this max point to this point right here, that's a distance of 1. So your amplitude here is just 1. That's the length. You don't want to count the full length because amplitude only deals with, hey, from the center line, how high did it go? Or from the center line, how low did it go? You don't want to count that whole distance, just half of the distance from that center line, okay? So on this one, your amplitude is just a 1. It does change. We'll see some examples later where that changes. All right, so let's go to cosine real quick. So cosine, I'm going to go a little faster here just because I think we've introduced the basics of it. But cosine has a different values, right? Cosine are your x values. So going back to your unit circle again, same key locations, 0, 90, all the way around. Now we're going to be looking at the x values. So look at that. X values start at 0, starts at 1, 0, -1, 0, and then back to 1. So it has similar numbers, but in a different order. That's the key thing. It's a totally different order. You'll see the same numbers, 1, 0, -1, but they're in a totally different pattern, and that is key, okay? So cosine, if you go back to 0, cosine actually starts at 1. At 0 degrees, the cosine value, the x value is 1, +1. So here we go. Starting with cosine at 0, our starting point is actually here at +1. This is where a cosine graph starts. It starts at 1. So notice it's on a high spot there. Then when you go to 90 degrees, it goes to 0. So pi over 2, it goes to 0. At pi, which is the half turn, it goes down to -1. So -1 down here on a low. Okay, from that -1, it goes back up to 0. So at 3 pi over 2, if you go look at your x value, it has a 0 value for your x value. And then if you go all the way to the beginning, remember, where did it start? 0 degrees started at 1, and it's going to end at 1. The x value is still 1 at 2 pi. When it makes a full turn back to the beginning, it ends at 2 pi. So coming back over here and making your mark. All right, so this has a totally different look to it. In fact, if I had to eyeball it and I looked at those points right there, I would say, oh, it looks like a V. It's a perfect V. It really does look like a V, but remember, we're not going to draw stick figures, right? These are waves. So it's gonna have like a dip down, like if you're going down a ditch in a road or something like that, okay? Some kind of a dip. Let's go ahead and connect those dots. Make sure they're curvy. You don't want them to look like a V, because if I were in the classroom right now, I'd say, hey, go back and do that. It shouldn't look like a pointy V. And excuse my graphing skills, it's not that great, but you get the point. Now, let's talk about pattern. So cosine graphs have different patterns than a sine graph. So we know it started at 1, we know it's ending at 1, but let's go ahead and do a pattern for cosine. Cosine has a totally different pattern, even though you saw the same numbers. Cosine starts on a high. Very key thing to remember. Cosine starts on a high. So if we're doing patterns for this, this starts high, then it goes to center, then the third point is a low point, back to center, and then it ends on a high. Okay, so take a look at that pattern. Different from the other one. A lot of same words, but again, pattern. Okay, cosine graph has high, center, low, center, high. So those are your patterns for a cosine graph. So they are totally different, totally different in terms of pattern order. That's your key thing. Sine graph starts at center, starts in the middle, but a cosine graph will start either on a high or a low. I say that because you could always flip your graphs. So sometimes it starts on a high, sometimes it starts on a low, just depends, okay? So keep that in mind for your pattern.